Guys, in the last video, I talked to you about two companies called Shimadzu and Agilent. And we looked at those companies because we were talking about an HPLC. So Shimadzu and Agilent. And we have an HPLC for each company. And we said that Agilent really is the leader in the HPLC world. Shimadzu's kind of making steps in that direction, but they are not as common as Agilent is. But Shimadzu's a huge company, and they're slowly and surely making their way into laboratory environments. So we have Shimadzu LC systems, we have Agilent LC systems. I showed you both of their websites, and I'm going to kind of do the same thing in this video, but we're going to focus on another instrument. And instead of HPLC, I'm going to erase the HP here in front, and I'm going to replace that with a GC system. And GC basically represents gas chromatography. Okay? So gas chromatography is different than high-performance liquid chromatography. And the reason is I don't see liquid in the name, right? I see gas. So what happens is that we have a box, just like HPLC. And with HPLC, what we had is that we had some liquids up here at the top. And those liquids got sucked into the machine and out the other end. And that's why we called it liquid chromatography. It used a liquid mobile phase. Well, with gas chromatography, what happens is that we have some type of tank that sits outside. And this tank is typically a helium tank. Not every single time, but helium is the most commonly used mobile phase in these systems. And what happens is that the helium gets sucked in to the machine and then finally out the other end. Okay? So that's why we call this gas chromatography. That is why this is different than high performance liquid chromatography. It uses a different media. And that medium is going to be helium. Helium is going to be the one that pushes stuff through the machine. If the helium is not present, then nothing will happen inside of the instrument. My sample will go in and it will stay there. It will not probably go through at all. Well, let's keep comparing and contrasting here. I said that the sample has to go in, so here's my sample. It's got to go in. It mixes with the mobile phase. Helium is the mobile phase. We used that term in the previous video, right? And that mobile phase, or helium, pushes sample through this instrument and out the other end. Okay, so when it does that, it has to go through a column, and that column is basically coiled up on a big rack on the inside. The reason that it's coiled is because these things are typically anywhere between 30 to 60 meters long. And they're about as wide as a strand of hair. So think about that for a second. I have a strand of hair that's about 60 meters. 1 meter is the distance between the floor to your waist. About 3 foot. Okay, well, I've got 60 meters. If 1 meter is about 3 foot, well, 60 meters is going to be about 90 feet in total length. But this thing is not wider than a strand of hair. And it's coiled up on a wire cage and put inside of a machine. It's kind of impressive. So that's why I draw it as a coil. In HPLC land, I drew the column as just basically a straight cylindrical type tube. That's how they look. GC world, though, they're a little different. Where does GC take its home? Okay, well, GC heats. So if there's molecules that cannot tolerate getting heated up, then this is not the machine for them. That's HPLC. That's its purpose. GC heats everything into a vapor, and the vapor gets basically injected onto the machine, and it separates the components just like it did in HPLC. And these component stacks get counted by a detector that happens at the end of the machine. And it provides me that data. It provides me, did it see anything, and if so, how much was present? So these things are very suitable for what we call thermally stable molecules. They can be heated up. They will not be broken down. They will not react. They will not get destroyed. By heating them up, you simply have just turned them into a gas form, and that's it. They're okay with that. They get injected onto this machine. They go through that column. They separate out into the individual components if it's a complicated mixture, and it comes out the other end. Okay, so for instance, gasoline. Gasoline has about 80 or plus components in it. Gasoline can also is very volatile. Very volatile means it could probably be thermally stable as well, and it can be a good candidate for GC, and it is. So the gasoline gets injected onto the GC. It gets turned into a gas, actually in a gas, and all 80 components begin to separate out from each other, and they come off of the machine one by one by one by one. The machine detects them. It tells me how much it counted, and then I use that data to do what I need to do with it. That's the purpose of GC. All right, so where is GC found? GC found is typically in the oil industry, oil and petroleum. You will also find it in the quality control side of the house as well, and you can find it in environmental applications. Pharmaceutical companies can have GC units. Most pharmaceuticals, though, are injected on HPLC. However, there could be maybe carriers, solvents, things that they will have to check as far as purity goes, that they will need to check with a GC system. So I'm not saying that GC is not found at a pharmaceutical company. What I'm saying is that if they do have them in-house, these are used for a different purpose. They're measuring probably quality of things. They're measuring the manufacturing process, various stages along the course of the way to make sure everything is in line like it should be. Chemical manufacturing side, right? If I'm making some type of chemical, whether that's maybe plastics or coatings that go on the cover of magazines, or maybe I'm distilling certain things at my industrial plant, and I'm taking portions of that into the laboratory to test and make sure they look pretty good. Well, that's the purpose of a GC system. So GC really finds its home in that area. Oil, diesel, gasoline, quality control, environmental, does great work with some pesticides and some herbicides. Great, right? But that's my GC system. The Chemical Technology Lab will have an Agilent GC, and it also has a Shimadzu GC. Both of them. Again, these are somewhat of the leaders, so we're going to give you an option to show you the differences between them. And what you'll find out is that there's more similarities between them than there are differences. All right, so here was the Agilent. Here was the Agilent website. I'm going to go to products. I'm going to go back into chromatography. And instead of liquid chromatography this time, I'm going to go into gas chromatography. And then down here toward the bottom, it will talk about GC systems and GC analyzers. So I'm going to click on GC system link. We're going to take a look at some of the GC systems that Agilent sells. And here is a 7890 GC system. Now, what we have in our laboratory, our Agilent, is a little bit older, but it looks very similar to this. Okay, there's hardly any difference at all. So what you will see in our laboratory is very similar to this. Up here on the top left, that is a auto injector. You can kind of see a small carousel here in front. So that allows me to load up a handful of samples at one time. And I'll just tell the software on the computer that I have multiple samples that I would like for you to inject. And then it will go through and it will inject them. I don't really have to worry about it. I just want to make sure it's doing what it's supposed to do. Here's a closer up version of the GC unit itself. On the inside of this machine, that's where that coiled up column would be. So there's a button right here to the bottom. I'm going to push that button and then this door would open up. And inside of that area would be a coiled up column that my sample will be injected into and that my sample will be separated out. What goes in has to come out. So the samples that I'm injecting into the machine does come out in vapor form out of the machine. So if I'm injecting something that's very hazardous, well, it's going to probably be hazardous when it leaves. So it's not uncommon to maybe see these things have some type of fume hoods on them, meaning that those fume hoods or exhaust vents would be turned on and it could suck up everything in and out of the lab and out the other way. Here's another auto sampler attachment. This allows me to load up even more samples than what's already present versus the small carousel that's going to be right here. Okay? So an auto injector and an auto sampler. If I scroll down, again, they're going to break it down and they'll tell me a little bit about the machine. They'll have some videos about how the machine works. Again, I'll post some of these in Blackboard if I want you to watch them. And your assessments will come from the material that you'll see in those videos. So again, it's just an acquaintance. That's all that we're after right now. Just getting acquainted with the technology that's in the laboratory. So this is the Agilent system, and I want you to take a look at this picture one last time because we're getting ready to go back to the Shimadzu website and we're going to look at their LC system. All right, so I'm going to click Products, and under the product type, I'm going to click Analytical and Measuring Instruments. Go back up to Products at the very top, and I see the link that says gas chromatography. All right, so I'm going to click it. Yes, I live in the United States. And I'm going to go down, and this is a GC2010 plus gas chromatograph. This is exactly the one that we have in our laboratory. So we did order a GC2014. This was the latest model that Shimadzu offered. It was going to be a great addition to our laboratory. The problem is that when the state inspector came, this instrument did not have a plug that had a UL listed tag on the plug. And because of that, we were not allowed to use the machine. Just simply because it didn't have the UL stamp. All right, well, we were not going to pay $5,000 to get this instrument to have a UL stamp. So we had to send the GC2014 back, and we got another GC2010 Plus. So we actually have two of these in our laboratory right now, and you're going to see it's very similar to the Agilent system, right? I see a box. This has a button at the bottom. I can push it. This door opens. There's a column on the inside of it, and this column will do the separation. There's an auto injector up here at the very top that I can put an auto sampler on as well. So just a small tray or a bigger, larger tray can come into the picture. But this is the GC system. And just like with the Agilent system, I can have a number of different videos with it, show me how to use it. But again, it's just general acquaintance. That's all that we're after. The GC system from Shimadzu and the GC system from Agilent do the same thing. There's no difference. The difference is the type of detection that you have. And we have a couple of different GCs for that reason, because they all see different things. I use one version of a GC to see one type of sample. If I'm using another type of sample, then another GC might be better suited for that. Let's talk about money. The Shimadzu GC system was around 30 grand. The Agilent GC system that we purchased, if you just take a look at that system only, with no of the other attachments that comes along with it, you're looking at about a 45 grand piece of machine. Again, the reason, they're similar, but one sees something different than the other one does not. I told you that we have two GC systems from Shimadzu. One is just basically a GC2010 Plus, right? The other one, though, is a GCMS system. So I'm not going to include that in this description. We're going to talk about GCMS on its own. But it is a gas chromatography system. There's just a big old chunk of something extra that gets added on to that piece of equipment. All right, so now we know a little bit about GC. We know it stands for gas chromatography. We now know that it's suitable for things that are very volatile, things that are thermally stable, that can be heated up without a problem. We know the lab areas that would heavily use a GC, and now we kind of associate a cost to the instrument as well. Keep in mind, that does not include computer. It does not include software. All right. So, watch the Agilent and the Shimadzu videos that I'm posting for you. Answer the assessment questions. Make a 100. And truck on to the next folder, which will probably be the GCMS instrument that we have in the lab.